All right, I wanted to take a minute and talk about where the heck did the quadratic formula come from? Some of you guys have seen this before or maybe heard of it. Maybe heard the Pop Goes the Weasel version, negative b plus or minus the b plus or minus the square root of b squared minus 4oc all over 2a. I'm going to go into where that came from. And it came from completing the square. You probably noticed when we were solving problems by completing the square or converting it to converting things to vertex form, you probably noticed some patterns, right? And so did other people. And so what they did is they solved for x in the general form. So here's our general form, ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. And so what they did is they solved it and they completed the square. Now we've solved a lot of problems by completing the square, but most of them have had pretty nice numbers that all worked out. So I'm going to go through an example where the numbers don't divide out evenly and all that kind of thing, and I'll have to work it with some fractions. And I'm going to do it simultaneously with the general form and derive the quadratic formula. Don't worry, this is just for your edification. You're not going to have to do it. So we'll start with this example. 3x squared plus 7x plus 4. And the first thing we're going to do is divide by that coefficient of x squared so that it becomes 1. In other words, in this problem, I'm going to divide everything by 3. And I get x squared plus 7 thirds x plus 4 thirds over 0 thirds, which is just 0. I'm going to do the same thing over here. Divide everything by a. And I get b over a, c over a, and 0. The next thing I have to do is I have to get rid of that constant term, right, so that I can create a perfect square trinomial. And so in this case, I'm going to subtract 4 thirds, and 0 minus 4 thirds is just 4 thirds. And I'm going to subtract c over a over here. And subtracting c over a from 0 just gets me negative c over a. Whoa, that's a lot of stuff. But as we know, to create a perfect square trinomial, you take half of b, and so half of 7 thirds, and square it, and adds it to both sides. So half of 7 thirds is 7 sixths, and 7 sixths squared is 49 over 36, right? 7 squared over 6 squared. Same thing over here. I'm going to add b over a is my b term, and so I add half of b, so which is b over 2a, and I'm going to square it, which is going to be b squared plus 4a squared. Now, I add that to both sides of the equation. All right, now we get some fun with fractions. So coming down here, this whole left side just stays the same, and I'm just dealing with the fractions. 49 over 36 minus 4 thirds. I need to find a common denominator, which will be 36. So I multiply the top and bottom by the same number, 12. So 4 by 12 is 48. 3 by 12 is 36. Then I'm going to do my subtraction. 49 minus 48. 49 36 minus 48 36 is 136. So now we've added b over 2a squared to both sides. Now, let's do it over here. So b squared over 4a squared minus c over a. So my common denominator is going to be 4a squared. So I need to multiply the top and bottom by 4a. And when I do that, 4a times c is 4ac. 4a times a is 4a squared. And then I can simplify. Now I have common denominators, right? And I'm going to get b squared minus 4ac all over 4a squared. All right, now, after we've done all that, then the whole purpose of doing that is to rewrite this side, this left side, as a square of a binomial. And so I know that it goes parentheses, x, that sign, and then half of this, and we know that half of this is 7 sixths squared equals 1/36. Then I'm going to take my square root of both sides, and I'll get equals 1/6 and equals negative 1/6. So now how do we do that over here? So I've got b, so first I rewrite this, so b over a, half of b over a is b over 2a, and then I'm going to take my square root, and I can't do much with that, so I'm just going to say plus or minus that square root. But I can actually simplify this a little bit. Let's look at that. Now we know that a square root of a fraction is equivalent to the square root of the numerator over the square root of the denominator. Now I do that because, look, I got some perfect squares in there that I can simplify. And the square root of 4 is 2, and the square root of a squared is a. Now, so now I'm here, and I've got x plus b over 2a equals plus and minus the square root of b squared minus 4ac all over 2a. Now, last step. I'm going to subtract 7/6 over here. And 1/6 minus 7/6 is negative 6/6 or negative 1. And negative 1/6 minus 7/6 is negative 8/6, which is negative 4/3. I do that over here, and I've got negative b over 2a plus and minus the square root of b squared minus 4ac all over 2a. I already have a common denominator, so I can just rewrite them like this, where I have b plus or minus this negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm there. I have the quadratic formula. Now let's see how we work with this. Here's an example. This is the problem we just did, and we know that the solutions are negative 1 and negative 4/3. See, they're right there. And in this case, looking at this example, my a equals 3, my b equals 7, and my c equals 4. And I'm just going to plug those into the quadratic formula. Here's the quadratic formula, and I really recommend putting parentheses wherever you're substituting in numbers, especially when you're dealing with negative signs, because it really helps clarify things, in particular this one here, because anything squared, anything negative squared is a positive number. But I digress. Let's continue on here. So I plugged in all those values. B's, A goes here, C goes here, A goes there. And then I just start evaluating, and you just have to go with PEMDAS and work your way from the inside out. 7 squared is 49. 4 times 3 times 4 times 4 is 48. And then I'm going to say, and 2 times 3 is 6. So I've just done all those simple ones I can do first. Then 49 minus 1, or 49 minus 48 is 1. And I know that, and then I split this up at this point. 7 plus the square root of 1 is 1 over 6. And then I simplify that, and I say negative 7 plus 1 is negative 6 over 6 is negative 1. And then I do the minus side, so negative 7 minus 1 over 6, which is negative 8 over 6, which is negative 4/3. So the keys, so that's how you use the quadratic formula, where it comes from and how it is used. And once again, we just go and we use this, we plug in the values, right, based on the quadratic formula, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. We plug it in to the equation, negative b squared plus 4a plus and minus the square root of b squared minus 4ac all over 2a. Just plug those in, work from the inside out, split it up after you have the square root, and chug along. Hopefully this will be useful, and we'll do a set of homework problems on the next class period. Thank you very much.